Hi everyone, welcome to my YouTube channel. Today I'm solving Leetcode question 424, longest repeating character replacement. You are given a string s and an integer k. You can choose any character of the string and change it to any other uppercase English character. You can perform this operation at most k times. Return the length of the longest substring containing the same letter you can get after performing the above operations. Example 1. The string length is ABAB, k equals 2. The output is 4. You can replace the two A's with two B's or vice versa to get the substring containing all same characters. And then in example 2, the string is given and k is 1. In this case, the optimal strategy to get the longest substring is to replace the 1A in the middle with B. So in that case, you have a substring of length 4. It contains all B's in this substring, and then that's the longest substring with repeating letters. So the output is 4. So how to find this problem? How to solve this problem? This is another sliding window problem. So understand the problem a little bit better. This is equivalent to solve the problem to find the maximum length of the substrings contains length minus k number of the same characters. So which means, okay, we first consider, forget about find the longest substring. First considering find a substring containing the same letter. So in that case, in this substring, the number of different characters should be less than or equal to k, so that you can replace these different characters to another character to form the substring containing all same characters. So that's kind of forming the qualifying substring. And then after finding the qualifying substring, you still keep moving the sliding window because you want to find the longest one. So you are comparing the length. So to solve this, we use two pointers, start and end, to keep track of the start of the substring and then the end index of the substring. So first, at the very beginning, the start index should start at position 0, position of index 0, and then your end index is also start here. So for the substring starting at index 0 and at index 0, so it only contains one character. So this is definitely a substring containing the same letter because it's only containing one character, and then this substring has a last one. And then you are trying to, let's say for this example, you are trying to move your end pointer to the right. So now you are forming another substring. That's a substring A and B. So for this substring, you can replace one character because your k, the value for k is 2. So you can replace one character to form a qualifying substring of all the same characters. So in that case, you can either replace A or replace B. So in that case, you will have another substring containing the same letter, and then the length for this substring is 2. You compare with the length of previous qualifying substring, which is 1, and then this 2 is greater than 1, so you are updating this one, the maximum length you are finding so far, to 2. And then you continue moving this end pointer to the right. So you are expanding this substring. So now the substring is ABA. Similar as before, you can either replace 1B with A, or you can replace two A's with B because the value for K is 2. So in that case, you have a substring that's containing the same letters in that substring. So the length for this new substring is 3. And then you continue move the end pointer to the right to expand this substring because you want to get a longer substring and you want to check if this longer substring meet our requirement. In this case, our requirement is this substring should contain the same letter after we perform the replacement at most k times. So in that case, you can see that here we have a substring of length 4. And then for this substring, we can replace either the two A's or two B's to get a substring containing the same letter. So in that case, that's why our output is 4. So let's take a look at example 2. So in this case, so similar as before, our end pointer, start pointer, both start at index 0. And then we start with the substring of last one, and then substring of last two. So AA is also qualifying. And then we continue move our end pointer to the right. So AAB is also a qualifying substring because we can replace this B with the A. So we get a substring containing all the same letters of length 3. And then we continue move this one to the right, move our end to the right. So we have a substring of length 4. So in this case, we can replace this B. So we have a substring starting at index 0, ending at index 0, 1, 2, 3, 3. At index 3, and then this substring has length 4, and then it will contain all the same letter A after we replace this B with a letter A. So now we have find the substring, qualifying substring, and then the length of that is 4. And then we are trying to move our end pointer to the right. And now we'll realize that, okay, this substring, no matter how we replace the character in this substring, it will not be a qualifying substring, which means, okay, after we replace some characters, we will not have a substring containing the same letter because this substring has two different characters, A and B. And then A appears 3 times, B appears 2 times. So the value for K is only 1. So in that case, we are only allowed to replace one character. So in that case, we cannot form a substring containing the same characters. So in that case, we pause our end pointer here at this position. And what we are trying to do is we are trying to move the pointer, the start pointer, to the right to see if we can reform a qualifying substring. So in that case, this substring ABAB is not a qualifying substring. So in that case, what we are trying to do is we're trying to continue move the start pointer to the right. So we have a new substring BAB in the middle. So in that case, this BAB will be a qualifying substring because we can replace this character A. However, it's smaller. The length is actually smaller than the maximum length we have found so far. The maximum length we have found so far is 4, but this one, the length, after we replace one character, the length would only be 3. So we do not update of the maximum length we have found so far. And then in that case, we already find a qualifying substring. So in that case, we pause our start pointer here, and then we are trying to move our end pointer to the right to see if we can find the substring with a longer length. So in that case, we find another qualifying substring. It's BABB, and then we can replace this character A with B. In that case, we find another substring of length 4. So the length is still 4. And then now we are trying to move the pointer to the end pointer to the right. So BABBA, so it's not qualifying substring. So in that case, we are trying to move our starting pointer to the right again. In that case, it's ABBA. It's not a qualifying one. And then we're trying to move start pointer to the right again. It's BBA. So it's so this substring, the length of it is actually less than the length of the longest substring we have already found. So in that case, our output is just 4. So that's kind of the overall idea for using the 2 pointers, start and end, to indicate the start position and end position of the substring. That's kind of how we solve this problem using the sliding window. So in this case, the count complexity would just be O(n). So to solve this, we need to keep track of the number of occurrences for each character in the substring, and then we use a dictionary to keep track of that. So the key is each character or each letter. The value is actually the number of occurrences in the substring. And then we are keeping updating this dictionary while we are moving the sliding window. And we also need to keep track of the maximum number of the same characters in the substring. So, and we use a variable maxSame to indicate that. And then we are trying to decide if we can form a qualifying substring. So in that case, we compare the maxim with the length of window minus k. And then, well, the maxim is less than the length of window minus k, which means in this case, okay, you cannot form a qualifying substring. What we did before, while we were trying to validate our idea with this example, we are moving the star pointer to the right to see if we can reform a qualifying substring. So that's kind of the main idea for solving this problem. So now let's start coding. Consider the edge case. If the length of S is 0, we have an empty string, we just return 0 directly. If now, let's try to first construct a dictionary. So let's use the default dictionary from collections. So we initialize, so to indicate, okay, the key, the value is actually the integer type. And then we use a maxim to keep track of the, okay, maximum number of same characters in the substring. We initialize that to 0. We also want to keep track of our the max string. Now it's an empty string at the very beginning. We also want to keep track of the start, the 2 pointers. And now let's just try to loop through the entire string S for n in range length S. While we are moving our n pointer to the right, we need to update our dictionary. So in that case, dictionary as and, so we have encounter the character at its position. So we increase the count by 1. And then we are trying to check if this as and is greater than the maxim we have got. If it's greater than that, we just update this maxim. And then after that, we need to check if we have form a qualifying. So this is we actually have a valid substring. So valid substring means, okay, contain the same letter after performing at most k character replacement. So in that case, we are checking if the max same is greater than or equal to the length, so which is n minus start plus 1. That's the length of the substring. And then we utilize that to minus k. If the maximum same is greater than or equal to this, we just update this max, and then we are comparing if the length of this substring, which means n minus start plus 1, if it's greater than the length of the longest substring we have found so far. In that case, we just update the longest substring. And then what if we can't form a valid substring? If we cannot form a valid substring, we just move the start of the start pointer to the right until we can form a valid substring. So if we cannot form a valid substring, we just keep moving the start pointer to the right. Before doing that, we need to update the number of occurrence for characters in this substring by remove this character from the substring. And then after that, we just update the index for the starting pointer. And then in the end, we just return the length for the for the longest substring. Okay, so after submit this one, we actually successfully passed all the test cases. So we have a working solution right now. So let's revisit the solution. Let's revisit this part. If we cannot form a Y substring, so we update the dictionary that keeps track of the number of occurrence for each character in the substring by remove this character from the substring. So we update its occurrence, and we also update the index. So you may be a little bit confused. Okay, but this max same, this is not actually being updated. So is it possible that, okay, we are actually removing some of the repeating characters from this substring as we are moving the sliding window to the right? Yes, you are right, we can do that. But we do not need to actually update this max same. Let's say uh, previously, if we find a valid substring, in that case, our max same is actually going to be the number of same characters in that substring. And then as we are moving, only when if we are can find a longer substring. In that case, we need to we can in that case then this max same will be updated. Otherwise, this max same does not need to be updated because that will keep track of the number of repeating characters in the longest substring we have found so far.